In this brief helpful video, we're talking about lesson 6 from our book, and this is scientific notation, ways to write really small and really big numbers so we can compute them a little bit easier. Use these next couple example problems to help guide you if you are stuck. Last week in our notes, we talked about this number 10 to the 5th before, and we said 10 to the 5th was the exact same thing as a 1 with 5 zeros after, and that turns into 100,000. So we said 10 to the 5th is 100,000. Now you're going to see problems in your book where it's going to have you take a number and then multiply it by 10 to the 5th. And so as long as you know that 10 to the 5th equals 100,000, you know you're taking 9.931 times 100,000. And we have one of those shortcuts about our rules when multiplying by tens or even now powers of 10, that we looked through those notes last time and we got all those different ways to move decimals. And so really, we're just saying that this is the same thing as taking 9.931 times 100,000, and all that does is that moves our decimal point, and we're going to move our decimal point 5 spaces. So now 9.931 turns into a decimal point of 1 spot, 2 spots, 3 spots, 4 spots, put a 0, 5 spots, put a 0. Your new final answer is 993,100, and we read that as 993,100. Just as our notes say, the exact same works opposite when you have a negative exponent up top. So if I'm taking 6.02 times 10 to the negative 4th, just be thinking about that we know that 10 to the negative 4th is 0.0001. So now if I'm actually multiplying 6.02 times 0.0001, I'm really just moving my decimal the opposite way. And so now 6.02, when multiplied by 0.0001, moves my decimal to the left because of that negative number. We're getting smaller. So 1 spot to the left, 2, 3, and 4, new decimal, and then zeros at every in between. So now my new number is 0.000602. So if I'm multiplying by 10 to the negative 4th, I'm just moving my decimal point 4 to the left. And if I'm multiplying by a positive exponent, so times 10 to the something else, I can move it to the right. Let's give one more example, and then you are good with scientific notation. At times I'm going to be asking you to compare different numbers, and the hardest part about comparing scientific notations is that we see all these numbers with one whole number, a decimal point, and then a series of decimal numbers less than 1 after that. So 1.22 times 10 to the 10th, 1.12 times 10 to the 10th, 7.15 times 10 to the 6th, and 1.06 times 10 to the 7th. The question would be, which is biggest? That's a bad W. There we go. Which is largest? And so the gut reaction when we first see this without really knowing scientific notation is to go with this number, 7.15 times 10 to the 6th. We see the 7.15, we notice that is way bigger than 1 point anything, and then we say, well, 7.15 has to be bigger. But in these, if we know that all of our scientific notations about decimal movement, we can see that we have 10 to the 10th, 10 to the 10th, 10 to the 6th, and 10 to the 7th. That means in these top two numbers, we're sliding our decimal place 10 places to the right, meaning that we're going to get way high, I think somewhere in the probably upper billions, maybe tens of billions, something like that, just thinking that through my head. So now if I'm looking at these two, and I'm moving these 10 decimal spaces, this one's only moving 6, and this one's moving 7. Still really huge numbers down here, but nowhere near comparable to these two. So I'm going to cross these two off as options. This is nowhere near the biggest, and this one absolutely can't be. So now between these two, now we just come down to our decimals. Now we're comparing numbers since our exponents are the same. Now we just look at 1.22 versus 1.12, knowing that 1.22 is larger because of the 1 and the 2 in the 10th space. We can rule out 1.12 times 10 to the 10th, knowing that 1.22 times 10 to the 9th is larger than every single problem there. All right, hopefully this helps. If you have more questions about scientific notation, make sure you email me, come talk to me, or be ready to ask questions during class. Good luck.